Hello everyone, welcome to the 32nd webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. While we wait for everyone to finish joining and get comfortable, I'll launch a polling question. You'll have about 30 seconds to answer about how you currently plot your PPFs, and then I'll show the results. Okay, it looks like most people are exclusively using the PPF editors, but we've got some people using chains as well and a few beginners, so welcome everyone. Okay, let's get started. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capability of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The first 31 webinars from this training series, as well as the 27 webinars from our Industry Solutions series, are available on our YouTube channels if you missed those. During this live presentation, you'll be able to type your questions along the way. We'll put some instructions on the screen. We'll answer as many as possible of those throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar, Tips for Using 12D Model Plot Parameter File Editors, will be presented by Owen Thornton, who's been writing software for 12D Solutions since 2003. Owen has over 15 years of professional experience in the civil and mining industries. He is the original author of 12D's Drainage Network Editor and the Drainage Analysis module, and is a 12D specialist in drainage, utilities, plot parameter files, survey conformance, volumetrics, and system setup. This webinar will demonstrate some of the new Public Works PPFs which 12D has developed recently for 12D Model 12 and beyond. We'll also explore customizing plotters, colors, plotter mapping files, etc. to produce PDF plots directly out of 12D very quickly, building up a drawing set as an array of 12D plot models before creating PDFs or DWGs. Over to you, Owen.
Thank you, Lisa. Hello, everyone. Yes, today we're talking about the PPF editors and tips for using them, highlighting along the way most of the new features that have been added to version 12 to the PPF editors. Now, this is a very broad topic, as some of you may be aware. Each PPF editor on its own is a large piece of software with hundreds and hundreds of parameters, and we're going to talk about most of them today. You know, things like plot frame PPFs, long sections, cross sections, drainage long sections, and even a little bit on drainage plans. Along the way, as well as showing the new features, I'll also be showing some of the new PPFs we have installed in the library in 12D Model version 12. And these have been configured to pre-configure some of the new features that are available in the PPFs now. And so if you have your own versions of PPF editors that you use for your jobs, it may still be worthwhile investigating the ones we install in the library that have some of the new features pre-configured, and we'll show you some of the examples that they can produce. I'm also going to be showing a method for pre-processing corridor model data. Anytime you're doing a section plot, whether it's a long section or a cross section or a drainage or sewer long section, you generally need to show a whole lot of crossing service information or anything that crosses the primary section. Things like property boundaries and crossing strings and other things like that. And anyone who's done any kind of service coordination job in civil design knows how hairy that can be. You're getting data from a lot of different sources, and my recommendation is to pre-process that and get it more manageable so that it makes the job of setting up plot parameter files to plot this stuff a whole lot easier. So I'll be showing that as well. And as well in this presentation, I will be touching on batch plotting, either with chains and 12DPL macros, 12D programming language macros, very simple macros, but they can be configured, either one, a chain or a macro or both. They can be configured to produce a whole series of drawing sheets and combine them into a multiple page PDF, a single PDF of a complete drawing set, if you like, that covers several different civil disciplines. So in version 12, I've got a list here of all of the PPFs we ship in version 12, and the ones highlighted in blue are the ones that are new to version 12. So you can see there's quite a few new ones, and most of the new ones have this PW in the file name. So for example, for the long section PPFs, all of these ones with PW are new to version 12, and they only really work in version 12. The ones that aren't highlighted were in previous versions as well, and we keep installing them there. And it's all of these PPFs are installed in the same location in the 12D library folder that's installed with 12D, normally under program files, as shown here. Now, in the case of the long section, for instance, I've got 4 different variants installed for these PW, or Public Works, it stands for. And these have come about via collaboration with a lot of different councils, where they have provided examples of the kinds of drawing standards that they like to see for their kinds of jobs. So they might not necessarily match with all of the state road authorities if they have their own standards, but these are a good standard for council work, and that's what the PW initials in the file name is there to represent. It's good examples, and we're going to sort of make this a new additional standard suite of PPFs installed with version 12 and beyond. So in the case of the long section, I've got 4 basic long section, or 4 long section ones for ordinary road long section, say. And there's different configurations there. The 2 basic ones are for when you don't necessarily need to show a lot of crossing service information. And the one with SE in the name also has a super elevation diagram on it. And a lot of work has gone into that. We'll be showing that a bit later. And the one with services in the name, therefore, when you do want to show a lot of crossing service information, and there's a dedicated spot on the sheet for displaying this extra information, which can be, a huge bulk of the information on the drawing, as well as the, the ordinary, the basic long section. And there's one with or without a super elevation diagram there as well. So there's 4 different possibilities or starting points installed in the library there. You can read any one of these straight from the library, and typically if you'll need to modify it to specify what string you want to plot and what output file and all of that sort of thing, you'll typically save it, not back to the library, but to your project folder. There is also a Public Works PPF in here for pipeline plotting for people who are starting to use the superalignment pipeline or even the old pipeline string. This PPF, using the ordinary long section PPF editor, is probably the preferred alternative now. If you look over on the right-hand side here, these are this is the plot menu basically that I've created an image of here. And we still do have a pipeline long section plot and even a Melbourne Water long section, but they're largely considered deprecated now. So whilst if you've got an old one, they still work, but all of the functionality of these 2 plots has largely been deprecated and absorbed by, in the case of Melbourne Water, in the drainage long section, and in the case of pipelines, all of the functionality there is now has been absorbed into the ordinary long section PPF editor. So for the cross-section PPFs then, again, we've got 2 new Public Works variants, one for when you don't need to show too much in the way of crossing services, and one where you do, and again, it's got a dedicated space on the sheet, extra space to show all of this extra information if you've got services. Drainage long sections, we've got one for stormwater or drainage and one for sewer. Now they're 2 quite different looking plots. Sewer and stormwater are quite different things really in the kinds of details that they show. And they are primarily based off drainage and sewer being so localised. They are primarily based off the councils in Queensland, And in fact, the drainage PW, Public Works one, is quite similar to the Queensland Urban Drainage Manual standard, which we continue to ship. I would say, though, that the Public Works ones is a little bit neater and slicker looking than the QDM one, but they both still work. And the sewer one, again, is primarily based around the conventions used in southeast Queensland more than anything else. So whether or not they're going to be applicable into a wider area than that, they may be. They're certainly good examples, and again, they have a lot of the new features configured in these PPFs, so that if you'd like to use the new features of the PPF editors, you can certainly have a look at these ones as a starting point. Now, the biggest list here is the drainage plan PPFs, and a lot of these, most of these, in fact, all of them have their purposes, and most of these have been shipped with 12D model for many years. But the ones highlighted in blue here are new. These are not Public Works ones; they are yet to be finalised. But we have got two variants here for design and one for final plan. So the design one has a lot more information on hydrology and hydraulics, specifically for rational method analysis, and one is set up for if you're using the generic or standard drainage.4D that ships with 12D, and the other one is if you're using the one that uses the Brisbane City Council or Queensland pit and pipe types there. So there's two different variations there for generic and effectively Queensland. And also the plan one. Now these are for final plan drawings, and they do structure names. They're simplified. They don't have all the hydrology and hydraulics details, and they're suitable for any kind of analysis, but they're more for your final plans where you simply show the structure names in some kind of bubble, and you show the pipe sizes and flow arrows and things like that, as well as symbols for all the structure types. So these are all the PPFs that are now new for you to have a look at, and a lot of them have all of these new features in version 12 pre-configured. So the first thing I wanted to show before we even get to doing any plots is to talk about crossing service data. So cuts and corridor models. These are the things that can often take up the greatest amount of time when configuring your plot parameter files. If you need to consider a lot of crossing service information, it can be a nightmare if you've got data in a sort of difficult to manage configuration. So what we have come up with is a recommendation really, and we've got a chain that's now installed in the library here. See this $lib create PPF cuts.chain. You can load that up from your version 12 installation and have a look at it. And I've got a copy of it here, and under the general comments section there's a note saying this chain is intended to pre-process crossing service utility boundary strings into new models for use in the corridors and cuts branches of all PPF editors. This makes the PPF management much easier. So the idea is, if I look at the two views on the right here, we might have some original data, and again, this is a simplified project I'm showing because I've only got an hour. But you can get all sorts of data. In this case, I've got cadastral data, which is your property boundaries showing up in magenta here, and they've got a particular survey code, SV/RP. And you've got two different drainage models, one for longitudinal drainage and one for cross drainage, drainage X. So that's our drainage X there, a culvert, and this one's a road pit and pipe network. I've got two different models for sewer design. One is the basic sewer model in brown there, and there's another one with the extracted property controls, which people sometimes also want to include in their plots for crossing services as well. Not always, but in this case I have. And then any other communications are in these, any other services are in these UT models here. And so this data could have come from a variety of sources. Some could be survey information, some could be proposed, all sorts of things. Some of it's 2D, like the cadastral data is typically 2D, so it doesn't have Z values, and you need to treat that separately. And most of it, though, has levels. And we need to come up with a simplified way, because if we have, say, even this list of models is too big in my opinion, but often the list is even longer. And you don't want to have to list every one of these models and treat everyone differently in a plot parameter file. You'll be there all day, and you'll have to do that for every plot parameter file as well. So we've got this recommendation here where we copy all of these data. We leave the original data untouched, and we copy all this data to a smaller number of models with well-controlled names. So they all begin with PPF cuts, and I've got separate models there, and I've separated the 2D data, like the cadastral data, from the drainage data, from the sewer data, and from the remaining utility data, which is everything else basically. At the same time as the copy into these new models, we've also renamed all the strings. And the renaming is a simple way. Basically, the reason why you'd rename it is a lot of this coding information is not what you want to appear on the plot. You want something a bit more human readable. So we've renamed all of this via a map file mainly, so that sort of the W strings show up as water strings, and all the different names used in the sewer model and the drainage model show up as sewer and storm. And the T string there, which is telecommunications, the red one shows up as comms, and so forth. So I'll jump into 12D right now and show you how this chain works. What I have here is a simple project that's just got 3 roads with some curb returns and cul-de-sacs and so forth, and a number of different services meandering through the job. Some of them run along the road, some of them cross the road. And a superalignment of control, well, a model of superalignments, which are all the control lines of the road. So here's all my design strings, the superalignments, the drainage, sewer, and UT data there. And I have in mind that I want to produce a drawing set of, in this case, a simplified drawing set of 16 sheets, where I've got a cover sheet, a number of road design drawings, which include plans and long sections and cross sections, a drainage section where I've got a drainage plan and a couple of long sections for the longitudinal or road drainage, and also the cross drainage like the culverts, and also a sewer long section, and also a section of this existing gas main that is meandering through this site as well. Sometimes need to do that. So that's what we're trying to do here. And by the way, this table, which I came up with, this was produced with the CAD, new CAD table option under CAD table. And it's just in a model called cover sheet. And I've created a simple plot frame. So yes, it's a very simple cover sheet. Doesn't have a whole lot of extra information, but with a title block, you'll be able to fill in extra information around the bottom too. Now, that table came from a drawing register. Now, I've previously given a webinar where I discussed the drawing register. And my drawing register is local to my project. It's sitting in my working folder, and it's a simple thing where I've got all of the 16 sheets predefined. These are all of the plot file names that I'm going to get 12D to produce, and 12D will look these up, and anything on the matching row that it finds for each sheet, we'll be able to put this information on the drawing through the title block mechanism. So all of the drawing numbers are defined by here, all of the sheet numbers are defined from the drawing register, and so forth, and we can control it all from the drawing register. Now I've taken a small subset of this table, and over on the cover sheet, I've just created effectively the table of contents that I want to appear on the cover sheet, and I've saved this sheet away as a CSV file, and within 12D, I've simply used that CSV file to create this table and plonked it on a sheet, and that's my cover sheet for this drawing set. Now we want to talk about pre-processing the utilities or the crossing service model. So I've got all my original service models here, and I've got a chain in this project. I've got a couple of chains, in fact, but I'll open up this one, plot PW PPFs. This is a chain I've written specifically for this project. So I'll open up the chain editor, and it looks something like this. Now, a lot of the stuff here I've disabled. I had originally set this up plotting each individual PPF in this project through one of the chain commands, but I've made a note there that, hey, that's a boring way of doing it. And as an alternative, I've disabled this, and I've got an alternative, because this plotting through the chain commands, it's entirely dependent on how you set up each PPF. Each PPF could be set up to plot to a different plotter and all of that, and you want more control over it than that. One might be set up to plot to a model, one might be set up to plot to a DWG, one might be set up to plot to PDF, but let's say you want to plot them all to model or all to PDF. Well, one of the things that I'll be showing at the end is this macro. Now, this is a custom macro that's just no interface at all. It's just something that you can code up and then compile from a 4DM into a 4DO and run it in a chain. And this macro I'll be showing at the end is set up to plot all of these PPFs, but not just using the parameters set in the PPF. It will override certain parameters so that it will automatically plot to model and to PDF at the same time. And it will plot all of them in one fell swoop. So I'll get 16 sheets of PDFs, 16 separate PDF files produced from this macro. Before we get there though, I want to have a look at the first two commands in this chain, the pre-process crossing strings. And it's running a chain called create PPF cuts chain, exactly the one I just showed you in the PowerPoint. Okay, so let's open up this chain. And we might just run this one to show you what it's doing. This is, in fact, pretty much identical to the one that you can also find if you browse to the library. There's a number of chains in the library, and the Create PPF Cuts is to be found in there. I'm running V12 C1J, by the way, which is the latest release version available. And if you're already using version 12, I would recommend you upgrade to that one. Because it's fixed a lot of things, and it's a very stable version. Okay, so looking at the comments section here, I've already sort of covered the first part of it, but all of the strings we specify, or all of the strings we're interested in, are copied to new models called PPF cuts something. So in the first case, the first command here just simply cleans all of any existing models called PPF cuts. I then copy the UT models, and I'll just bring up the preview of what that's doing. That is this panel. So it's basically copying all of the 2D data and the basic utility information, not the sewer and the drainage, we're doing that separately, into a model called PPF cuts UT. From that UT model, the PPF UT model, we then map it. So the map file here, and this is where most of the work is done in the map file. We simply process this model that we've just created by copying certain data via a map file. And this is where it's going to be different for every different job, because you basically go to the, well, there's instructions on the header branch there of the map file editor, but on the basic branch, all we really want to do is identify all of the different string codes that we can find in this model and assign a new name to it. So rather than having GA lock or T or W appear as the label on the plots, we want something that's more human readable. So we can rename it there and also assign it to a new model. So all of this, anything that doesn't have a level gets mapped to a 2D model, and that's the survey code there for the property boundaries. And anything with a level gets mapped into this UT, and we treat them separately in the PPF. Anything that we've missed will be mapped into a model called PPF cuts unmapped. Okay, so that's how the map file works. In the case of drainage and sewer, they're both fairly similar, but basically you copy all of the drainage data. So your two drainage models in this case, long drainage and cross drainage, and we're putting it into a new model, combined, a single model called PPF cuts drainage, and I've renamed all of the strings storm, because I don't care about the individual string names anymore for the purposes of the plots, or for the long section plots and cross section plots. I simply want a label to say this is a stormwater pipe or whatever it happens to be. Similarly, for the sewer strings, we're doing something similar there. And there's two different sewer models get renamed to sewer and put in the model called PPF sewer. So if I go and run this chain now, that has basically copied all of the information on this utilities view into the models we see here. There's just this much smaller number, and you can have, 10 or 50 or however many models of data here, and you can generally get it down, boil it down to 4 models, which is going to make life a lot easier when you come to set up PPFs. And all of the names are now human readable, so we don't have any of these strange looking survey codes or the all sorts of semi-random names you get in sewer models and stormwater models and things like that. It's all neatly controlled and easier to manage in this form. Okay, so back to the main chain then. I'll close this one down now that we've discussed what it's intended to do, and I would recommend this in general because it is a sensible way to go about controlling and managing your PPFs. But back to the main chain here, that main chain, first thing it does is run the chain we just ran there, and that cleans itself up, so I can happily rerun this. But then it skips over all of this. It's not doing any of these. You can see it's got the disabled symbol there, so it's not doing any of these commands, and it's jumping straight to my macro. So I'm just going to go and get that macro to run now by simply running this chain. And that's going to go off and produce models, plots to models for all of these PPFs, and also plots to PDFs. I'm going to leave it running for a little while I go back to the PowerPoint. The end result of the pre-processing of the corridor models is it means that in your plot parameter files, and here's an example of a long section plot, I only need to specify 3 or 4 models in the corridors branch and in the cuts branch. And the less models you have means less parameters to set, which means it's less time. Now, you'll typically need to do something similar to this for all of the different PPFs you need to plot, whether it's a long section or a cross section or a drainage long section or a sewer long section. But all of the new Public Works Services PPFs installed in the V12 library have been pre-configured this way. So that chain for pre-processing the corridors and cuts models is going to work nicely with those Public Works PPFs. Now, sticking on the topic of the cuts, one of the biggest and possibly my favorite improvement to version 12 is that the cuts annotations can now be positioned with staggered uprights that extend down into the boxes area. You could always put uprights on them in the past, but they were never staggered, and they would often cause clashing text, which needed to be touched up as a drafting exercise. Well, no more. All of the new Public Works Services PPFs have this dedicated space on the sheet for plotting this extra information. And typically it's the name of the service, and that was why we renamed the strings via that pre-processing chain, because this is what we want to appear on the plot rather than the original survey code, for example, or whatever the drainage designer or sewer designer or utilities designer used. We also want to show the size of the service, and also the invert level typically of the service. And those 3 bits of information take up a fair bit of space, and to avoid clashing, we've got these staggered uprights now, and they extend all the way down into the boxes where the values of chainage and heights and all of that at these locations will also show up. And so that is a huge improvement. And to do it, all you really need to do on the cuts branch, all of these sub-branches here have a new position mode called above top of boxes staggered. And it's as simple as that. As soon as you do that, the upright magically appears. You don't even need to specify a symbol or anything like that to make the upright appear. It just happens automatically. Okay. Similarly to the cuts annotations for cross-section plotting, you can also now insert staggered uprights for cross-section points. Now, often on cross-section plots, you need to display certain design codes, design string codes. So all of these cross-sections are made up of design strings where at each one of these vertices. You can skip ones. You can see here that I've skipped a few there where the curb and gutter is. You typically only need to show the curb lip, KL on the left, KLL, and KLR on the right, and KB for the curb back, for example. And then there's the other codes as well, the back of footpath, the interface string, and that sort of thing. And these, again, with the same position mode above top of boxes staggered, they can automatically appear alongside your crossing services. Again, there's this dedicated space on the services, the Public Works Services PPFs, to show this extra information and avoid text clashing. So they're all neatly staggered, and they observe one another's locations and stagger accordingly. You can also show the 2D data. Now there's our property boundary showing up, the registered property boundary, RPBDY, and that gets uprights. And also another feature of the cross-section plot is that you can now get uprights into the extension area there. Beyond the primary string that you see in bold, we can get uprights outside of the finished surface. And that's another new feature. There are other features that I'll talk about a bit later with the cross-section plot and controlling uprights, but those two are pretty good. Now I'll just go back to 12D now, and I think that change should have finished by now, and in fact it has. We'll just minimize the chain panel, and we'll have a look at what it's done. It has actually produced this array of plot models, and these are my 16 sheets. I've got 3 by 5 there and an extra one there. So this is my cover sheet here. I've got an oddity here, and I just did this to see whether it worked more than anything. I wouldn't necessarily say that this is a sensible thing to do, but I've got a drainage plan in here that's different from all the others. It's plotted to an A3 sheet rather than an A1 sheet. All the others are A1s, but I just wanted to show you that, hey, if you needed to do something weird like this, you can throw an A3 sheet into the mix as well. I've toggled the text off, but if you toggle the text on, we can see there's a huge amount of information that's just been produced by that little plotting macro, which is very similar to plotting via a chain, but it's a little bit more advanced, and you've got more control over the things you can do. But it hasn't just produced this array of plot models. It has also, if I look in my working folder, it has produced all of these PDFs. You can see the date modified there. They're all the current time and date, and all of these are now individual PDFs. We can open up any one of them. If I open up, say, the drainage plan, that's my A3 sheet there, and you can zoom in and see details. Now this was the annotations we see here for the drainage line are produced by one of the drainage plan PPF that I mentioned earlier, the one that's intended for sort of final design plans. It's only showing the structure names in bubbles and the pipe sizes and the flow arrows, and gives you all the symbols and all of that. But a lot of new features have gone into the drainage plan plot that's sort of beyond the scope of today's topic. That might be a separate webinar topic for the future. And because it's going through a drawing register, all the drawing numbers are appearing on the sheet there. This one's set up with a scale bar and a north arrow and all that sort of thing as well. So basically, we've got all these PDF sheets, but what we'd like to do now is to create a single PDF of all of these 16 sheets and control the order. Now, when I produced this array of plot models there, I wasn't really considering the order too much. They're not in any particular order. They're just in a nice rectangular array. I might just toggle that text off and go back to a reasonable size. But if I can bring back my Explorer window, to get all of these PDFs into a single PDF, there is a new option. Well, it's actually not new to version 12. I believe it's in version 11 as well. Under the File menu, Combine PDF Files. And if you open it up, it's actually fairly simple to fill in, but just to save a little bit of time, I've got a screen layout file of this panel pre-configured. So I'm going to load in my screen layout file, File, Layouts, Layout Input, Combined PDF files. There it is. And there is this input information. It's a little text file, and I've got one pre-set up there. I'm going to hit the read button, and that's going to populate the grid for me. And this has predefined the order, or I've already done this in advance, but I have predefined the order I want for all of my 16 sheets. Obviously, I want the cover sheet to come first, and then I want all of my 2 road plans, my 2 road long sections, my 6 road cross sections, then my little A3 drainage plan, which I'm hacking into the middle of all of these other A1 sheets. 2 drainage long sections, one for the longitudinal and one for the cross drainage, a sewer long section, and the existing gas main is also going to be plotted here. Okay, and I'm going to combine all of these PDFs into a single PDF called drawingset.pdf. And all I need to do is hit the combine button, and that will go away and do that. And I can open it up from the folder icon, click on the folder icon and open. And there is my 16-page drawing set. There's my cover sheet, very simple, of course. It's just an example. Using the standard 12D title blocks as well, which again, very simple, but they're good examples that show you how title blocks work. There's my road plan, first road plan with a grid, and I'll show you how these plans came about a little bit later. There's my second road plan, again, showing all the crossing service information, all the service information, as well as the chainage labels and so forth. You can see as I toggle back and forth between the first and second road plan, the north point is rotating in the bottom right of the sheet as well. And that north point symbol automatically rotates with the plot frame. Then we move into the long section of the road. And I'm only plotting the main road here. I'm not doing the 2 side roads in long section, just to keep this demo brief, or kind of in time if I can. But this one's got a huge amount of information. We've chosen to put on a plan component as well, which is an option that you can do. And that's pretty much the same information that was on the road plan, but automatically aligned and rotated with the long section plot there. So it automatically rotates the start and the end point, which you can see marked with these sort of eye-shaped symbols here. And this one's got all of the service and utility data. All the crossing services are showing up in multiple colors there. It's got all the vertical curve and horizontal curve information annotated. Labeling your, if I can zoom in there, labeling the horizontal tangent points with these little barbells, the vertical tangent points with circles, the crests and sags with the triangles, and the VIPs, the vertical intersection points, with little crosses. So a huge amount of information on here. We've also, of course, down in the boxes area got finished surface levels, existing surface levels, cut fill depths, chainages, and also a super elevation diagram. And that super elevation diagram is much improved over anything in previous versions prior to version 12. Probably, I've been told that out of all the work that went into the plotting for version 12, the super elevation diagram took the most time. It's a very difficult problem to draw a super elevation diagram, and I think the programmers have done a great job there. Onto the next long section sheet. One of the things you can see in addition there is we can also now do datum shifting. And I'll show, you can see there that the original datum, I don't know if you can see that at this scale, but the original datum at the beginning of the sheet is 24.5, and then at some point it's been determined that this can't fit between the plan component and the datum, and so the road section and everything else along with it that's being plotted has been shifted down, and there's been a datum shift there and a datum shift here as well. So that is also a new feature that I think will be highly welcomed in version 12. So back to the PDF for the PowerPoint for a second. Here's a little bit about the long section super elevation diagram, and the basic structure in the PPF editor is largely the same. However, there's this new mode, sample super using points on edge and hinge string. This is the most sensible mode to use unless you already have your super elevation defined as a part of your super alignment, your control line. We do also have a mode for drawing the super elevation diagram based on what's set on the super alignment, but in most cases you need to sample the data, the crossfall data, from actual strings in your design because it could have been modified from what the super elevation, the super alignment had. And there's a number of new tolerances here that you can play with, but in most cases I've found you simply need to set this super rotation rate tolerance in % per meter. And that is effectively the slope of the crossfall transitions on the super elevation diagram. Basically, you can measure it yourself based on how much the crossfall changes. In this case, it would be a change of 6.6% going from -3.3 to 3.3 over a distance of about, by looks of it, 40 meters. So 6.6 divided by 4.3 is whatever. Basically, you simply need to make sure whatever the flattest slope is in your crossfall transitions, you need your super rotation rate to be slightly lower than that. Anything flatter than whatever the tolerance you specify here will be determined by 12D to be a flat portion, and these are the portions that get labeled with a crossfall there. 12D is going through and identifying the diagram and looking for the flat spots and labeling the flat spots. And it's a much better looking diagram now. Another big plus is it also labels automatically the chainages at 0 crossfall. So where you have a crossfall transition passing through 0 crossfall, we'll get the chainage label at those points, say there and so forth. Okay, so that's a big plus. And as I showed earlier, the datum shifting. The datum shifting is controlled by a number of different parameters, and it is kind of job specific. You won't be able to set these parameters in a one-size-fits-all manner. It depends on the long section, but it is generally about setting this height calc method and experimenting a little bit with these different parameters in this section under the graph area branch of the long section plot, and you can generally get it to automatically datum shift. Now, though, in my example here, I haven't inserted an upright at the datum shift, but there is an option under the chainages branch, I believe, or the uprights branch possibly, to insert an upright where the datum shift occurs there. So that's if you need that, that is available as well. So I'll leave these PowerPoints rather than show this live because I'm running a little bit short of time now. I'm going a bit over. But I'll move on and show some of the other new things. This is a good one. If anyone does plot frame plotting, I use it all the time. In this case, this is the example of the two road plans that I produced. I created two different A1 plot frames in the same model there, frame A1 road 500. Both of them are slightly rotated from north and aligned to fit the road design in, a complete extent of the road design in nicely. Now, in the past, you always had to have a view set up. In this case, I've got this view plan road set up, and I've put a grid on, and I've put all of the tin on showing the contours and all design strings and everything else I wanted to show, all of the utilities and all of that as well. I don't technically need the frame on the view here, but that's just to show me how my plot frame is positioned. So I'm expecting two sheets to come out, the magenta one and the blue one, to produce two sheets. In the past, I always needed to maintain this view. And as you probably are all aware, over time, views can come and go. The things on the views can change. And if you want something repeatable, it was always a bit difficult. Well, in version 12, we now have a new mode here on the main page of the plot frame PPF editor, which instead of plotting a view with all the data on it, you can save the view away as a view favorite. So I might just show this one live as an example because it's a good one to know about. Back to 12D, I'll close down that and close down the chain. I don't need that chain anymore. And I'll just, on my plots menu, plots view I should say, I'll just show, these are all the plots it's produced, I'll just show the road plan there. That one. And these are the two sheets it's produced. I'll toggle the text back on like so. And that one was produced from the PPF editor. If I go to plot, edit, binary PPFs, plot frame, I've got one in here called plan road. I'll load that one up and hit the read button. It's already, I didn't even need to hit the read button. But you can see here, this one's set up to plot this view favorite called plan road 12D VF plan. Well, what is that plan view favorite file? Well, to demonstrate, I might take one of my existing views, so my design view, and I'm going to create a copy of it using the clone button there. So I'm just calling it design copy, and that's as soon as I hit the clone button, it's copied it, and I've got two views now, design and design copy. I'm going to take everything off this view, so it's got nothing on it at all, and I'm just going to hit the yellow star here. That's the view favorites, and I'll hover right on the favorites, and here's the file that the plot PPF editor is referring to. So in this case, it's the plan road one. If I double click on this, it actually reconfigures that copied view and renames it plan road, changes the background color, all of the settings there, and it's got all of the models that I'm interested in plotting. And this is a different set of models from the one on the previous design view. Okay, so I can reproduce a view from those view favorites, but I don't even need it to be up and running. I don't need this view in place, in fact, with a view favorite. And once I've set this up and saved it away, I can just go and create, using create edit, and save it away as a favorites file. Once I've got that, I can delete that if I want. So when we go ahead and do the plotting now, I can get rid of that view if I wish, and go ahead and hit the plot button here. And this one's setting up to plot to model, and it's just reproduced that plot. It's also showing the, oops, I shouldn't have zoomed like that. Probably just broke the internet. And here we can see it's also showing a scale bar on the north arrow. That is done under the title block symbols branch there. So just a little bit about things you can do with the plot frame and the view favorites, and also these symbols. I'll go back to the PowerPoint because that's the next slide, in fact, is showing how you can put a north point and a scale bar. The north point automatically rotates with the plot frame to point north, surprise, surprise, and the scale bar automatically scales to the designated plot scale. So we have a number of different scale bars of different lengths in there that you set with the scale mode plot scale, and it will automatically size to whatever scale you happen to be plotting at so that it actually fits and looks good. So I don't really need to show that one live because it's all on the screen for you there, all the settings that were used to make these work, and these symbols are straight out of the symbols file that's shipped with 12D. Okay, so we're nearing the end now, and I figured that I would be running out of time. There's quite a lot to cover in today's webinar. So I've just listed a few other things that that you may be interested in. Grids, if there's a new grids branch on the long section, the cross section, and the drainage long section PPF editors. For those people who want to draw an annotated grid in the graph area, there are a few drawing standards out there that show grids there, and that's available if you like it, or if you'd like to have a look at that. The cross-section PPF editor, I alluded to this a little bit earlier, But the cross-section PPF editor now supports uprights at regular intervals and also into the extension area, in addition to the traditional uprights that we've always had at the vertices of the primary cross sections. So if you just want uprights at regular intervals and not at the vertices, you can do that now, whereas you previously had to do a bit of a workaround to make that happen. These are all available. All of the settings to control this are on the boxes, uprights, offset, staggering branch, so you can have a look there. But for people who cut sections from tins, that regular intervals one will be the one that they'll probably be interested in looking at, because otherwise a section cut from a tin has a vertex wherever it crosses a triangle edge, and that could be sort of semi-random in many cases. So if you want more control over the uprights, that's a handy new feature. Generally speaking, across all the PPFs, a lot of work has gone in to add more controls for turning various parameters on and off, instead of having to delete a parameter or setting that parameter to 0. So there's now a lot more tick boxes. Some of them are 3-state tick boxes too, which means that if there's 3 states and the sort of maybe state means it's not defined in the PPF, that it probably is on by default, I believe. What I've already shown you, creating a multiple page PDF drawing set with the file combined PDF files. Again, that's available in version 11, but it's there in version 12 too, and it's becoming quite a handy tool. I guess there's lots of ways to do it outside of 12D as well, but it's built into 12D. And again, I alluded to this one before as well. Lots of new features in the drainage plan PPF editor. I haven't really shown any of them much today, other than mentioning a few of the new PPFs in passing. It's probably a topic for another day because there's too much to cover in one webinar. So the last thing I wanted to talk about now was this magical macro that I ran earlier on that produced all of the 16 drawing sheets, plotted it to model and to PDF. And how did it work? Well, because I'm not using any of these built-in chain commands, I've written this special macro. And look, chains are great for batch plotting. And in fact, I'm still using a chain. It's just that my chain is calling a macro. The 12D PL macros, 12D programming language macros, are better than the standalone chain commands. And these macros I'm talking about are very simple macros. They don't have any panel. They don't require user input to type things in. You pre-configure it all based on, in this case, looking at the top part of the code of this little macro on the right-hand side here. This is what the code looks like. It's a 4DM file, which gets compiled using the 12D menus into a 4DO or 4D object file, which is a macro object which you can run in a chain. Okay, so this is the source code, the 4DM for the 4DO that runs in the chain. And it's basically all you are required to do here is list all of the different PPFs you're interested in plotting. I also require you to specify the type here, and this is a number between 1 and 9. Now, all of the different PPF types that 12D has are listed here, and it requires this special text there. But I've created an array with indices there that we can use instead. So I can just set, in this case, 1 corresponds to a plot frame plot, 2 corresponds to a section cross plot, 3 corresponds to a long section plot, 4 corresponds to a drainage plot, and so forth. I'm not using some of the other ones, the Melbourne Water Pipeline, and even the rainfall files and design parameters, which are PPF-like files, can be modified with this macro code. The last parameter I'm setting here for each PPF is what plotter we want to use. Again, this macro plots the PPFs both to model and to PDF. And in some cases where I've got a mix of A1 and A3 sheets, I might want to choose, in the case of the PDF plotting, whether to use the PDF color plotter, this is one of the standard plotters in 12D, or whether I want to plot the PDF color 50%. One is intended for A1 plots and one is intended for A3 plots with thinner, basically half the line weight of the A1 one. So in this case, the one A3, the strange one in my drawing set, the A3 sheet, I've set with plotter type 2, which is going to set the PDF color 50%. Okay, and then it's a matter of looping through the PPFs. Now I'll show this very quickly, just to talk you through what it's doing. I'll bring up my working folder, and my 40M is just sitting here in my working folder, and I'll open it up in a text editor. And I've somehow managed to turn on all the funny characters, which I can't remember how to turn off. I am running a bit low on time. Why can't I remember how to do this? That's the one I want. Thank you. So we've already looked at the top part of the file there, where we've got some basic input data and all of these indexed arrays predefined. So I just need to match these integers to match the arrays here and here. But once we get, the rest of the code is only this long, and all it's doing is looping through each of the PPFs we've specified, creating a PPF file object here. I don't know if you can see this, so I might just make the text a bit bigger. Looping through each PPF, creating a PPF object of the appropriate type based on what we specified above, then actually reading the PPF file into the PPF object, the plot parameter file object, which is a special object type in 12 DPL. And once we've read it in, we are ready to go and plot it. But you can do more than that. In my case, all of my different PPFs were set up to use different drawing registers or no drawing register. And I wanted them to all use the same drawing register and set them all up in the same way. And so this set of commands here, and it's all the same commands, set parameter commands, I've just gone through for every PPF and set all of the drawing register related variables in the same way. So this one says this drawing register type. This one says use an Excel drawing register. This is the name of the Excel drawing register. The / means it's in the working folder of the project. This is the name of the sheet in my drawing register, the worksheet. And then it's matching the column in the worksheet called plot file with the value of the title block variable $plot file, which is automatically produced. And then these are the variables for matching the columns in the drawing register to the user text variables that are defined in the title block file. Okay, and these variables were all covered in the previous webinar I gave on the title block, but perhaps not in macro code. So here's what it looks like when it's in macro code. So that every PPF gets all the drawing register parameters set the same way, nicely controlled, and then we simply have another loop inside the main loop to plot it twice. The first time we plot to model, the second time we plot to PDF, and that's simply controlled by the one set parameter command there for setting the plotter type. And it's either model or whatever the plotter type is we set at the output, which is either the PDF color or PDF color 50%. And then this is the actual command that produces the plot. And that just loops through there. So the code itself is less than 100 lines long, I think, or just over 100 lines long. It's a very small macro, and you simply fill in the details to match your plot parameter files there, come back to 12D, and you go utilities, macros, compile your macro. It's gone and compiled it, and I now have a 40O that I can run in my chain. And that is how it's done. So I think it's a better way, if I bring back my chain, I think it's a better way to use these macros rather than the inbuilt chain commands for plotting PPFs, because we've got the ability to modify the PPF on the fly. You can even save the file back again if you want to save your changes, but you don't need to. You can just take an input PPF, modify things on the fly, and get them all. So if you have a great number of PPFs that you all need to be changed all in the same way, the macro is a great way to do that. You can then take it even further if you like with batch plotting and say, reuse, say, the PPF we had for, say, the road long section and apply it to all the other roads as well. And you can do parameter substitution via the macro language as well. And that's when you really get into some advanced batch plotting. I won't go into that at this stage, but they're very simple macros, very accessible for people who are even new to macro programming, and they're very easy to run. You simply put this one line, one command in your chain. So that's where I wanted to leave things today. And I think I've pretty much used up my full allotted hour. So it is probably time now to pass things back to you, and we'll see if there were any questions asked in the while I was giving the webinar, and I'll try and give an answer.
Thanks, Owen. Yes, we'll squeeze in just a couple of questions live. Bill in ACT has asked, what is the best way to modify plotters and/or plotter mapping files from the 12D defaults? Okay,
I'll go back to 12D to explain this one quickly. Let me load up a PPF for starters. So I'll just edit, say, one of my plot train. Yeah, I might just do the drainage one, say. Okay, now this one's set up to plot to model. If you click on the model box there, you get a number of different plotters defined, and the model plotter is defined as one of the inbuilt 12D plotters there. And all the PDF plotters we've been using are under the PDF branch there. And you can say, well, okay, for A1 plotting or full scale plotting, there's these choices here. And for half scale or A3 plotting, there's these choices here. It doesn't really matter when you plot to model, because basically the difference is the line weight that you produce, and that's controlled via the plotter mapping file. Now, where do all these plotters come from? They come from the plotters.4d setup file. You can make your own, and there's a user plotters file that you can add on to the standard ones, but generally speaking, they're in the setups folder. If I click on the little setups folder icon here, it opens up the setups folder, and under P for plotters, I've got a plotters.4d file. And this defines all the individual plotter types that we see on the list. Oops, sorry. Now, if I go to one of the PDF ones that we've been using, we were using PDF color, for instance, and that says it's in the group PDF full scale. It's using the PDF 12D plotter engine. It'll give the file a PDF extension, and it's got map pens true and map file PMF color.pmf. Now this file has just been specified with a file name with no path. And we install this file. There is a copy of this file in the setups folder. It's where the same folder that this plotters.4d file is set up. If you wanted to, say, modify your plotter mapping file, you don't have to create a whole new plotter mapping file, and you don't even have to rename it. If you simply take a copy of this PMF file from the setups folder and copy it to, say, your user folder, it will find your file before it ever finds the one here. So you can still use the same plotter. If you don't want to make a new plotter, you don't have to. You can still use our same standard plotters, but using your own plotter mapping file, the PMF here, and you don't even have to rename the PMF. You just need to move it higher up in the search path order. If you move it to the user folder or to the working folder of your project, it'll find it before it finds the one we install. So it's generally pretty straightforward. You don't even need to mess with renaming files. Just copy this PMF file to a folder higher up in the search path hierarchy so that it finds yours, and then you can modify the PMF, keep the same name, but just modify the contents so that, for instance, if you wanted a red color to plot in a different color, you can do that. If you wanted to change the line weights that so that they're different from the way we do it in our standard PMF, you can do that too. They are big files. They pretty much define every color that you have defined. And if you've created your own colors, you may need to modify the PMF to add in your customized colors as well. But that is the basic structure of how it works. The plotters come from the plotters.4d, and the PM, and they refer to plotter mapping files in a lot of cases, and they adhere to the search path hierarchy, as in look in the working folder, then the customer user, then the user folder, and then finally the setups folder, which is where we have installed all of these PMFs by default. Okay, so I hope that one covers that question.
Great, thanks. And John in Brisbane would like to know, can I get a copy of the project you've just shown with the chains and the macro code?
Yes, I will try in the next few days to make this available on the 12D Model Forum. So if you log on to the 12D Model Forum, probably I'll, not sure where I'll put it yet. I'll have to have a bit of a think about that. But it'll be a fairly small project. Once I delete all of these plot models and the whole array of plot models and all of the utility data, the PPF cuts data, it's quite a small self-contained project, and it's simply a matter of getting a copy of the project and running the chain to produce everything, and that will run the macro, and that it includes the macro code. So it's quite a nice little self-contained project, even though it might not be a particularly realistic design. It's quite a contrived little job, but it does demonstrate the new features quite well.
Thank you, Owen, and thanks to the audience for your questions. Sorry to those whose questions we couldn't get to live today. We're just a bit short on time, but we'll send you answers by email soon. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next training webinar is Inlet Capacity, SAG and on-grade locations on the 7th of November. Do keep an eye on our website for details of that one, as well as our upcoming industry solutions topics. We'll also continue to keep you posted through email and social media. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation. Thank you for attending, and we hope to see you at future webinars.